Welcome to the first module of our Agile course, the Paradigm Shift. In this module, we'll delve into the pre-Agile era, exploring the reasoning and motivation behind the industry's shift towards Agile methodologies. We'll examine the traditional waterfall model with its sequential phases and the iron triangle's constraints, highlighting the challenges they posed in a rapidly evolving tech landscape. We'll also address the application development crisis, which underscored the urgent need for a more adaptable, responsive approach. The module culminates with the year 2001, when the Agile Manifesto was introduced, signifying a pivotal moment in software development. This module sets the stage for understanding how Agile principles and practices have come to redefine project management in the tech industry. Let's begin our journey into the evolution toward Agile. Before Agile methodologies became a cornerstone of software development, the waterfall model dominated the landscape. This predictive approach to project management and software creation is characterized by its linear, sequential phases, where each stage depends on the deliverables of the previous one. The first phase involves gathering and documenting all the project's requirements in detail. This results in a comprehensive requirements document that guides the subsequent phases of the project. Following this, the design phase outlines the architecture and design of the software or project based on the previously defined requirements. During this phase, design specifications are created, serving as a blueprint for implementation. Next is the implementation phase, where developers translate the design documents into code. This phase focuses on building the software components and functionalities outlined during the design phase. It represents the core of software development and can be lengthy, depending on the project's complexity. Developers must adhere closely to the design specifications to ensure the project meets the predefined requirements. After the software is developed, it enters the testing phase. This crucial step aims to ensure that the software functions correctly, meets the initial requirements, and is free of defects. Once the software has been tested and approved, it progresses to the deployment phase. During this stage, the software is released and becomes available for use. Deployment might also involve training users and setting up the necessary infrastructure for the software's operation. The final phase of the waterfall model is maintenance. This phase is crucial for ensuring the software continues to operate smoothly and remains relevant to users' needs. Although it's the last phase, maintenance is an ongoing activity that can last as long as the software is in use, addressing any future bugs, updates, or enhancements that become necessary over time. The waterfall model, while offering a straightforward and easily understandable framework, has faced significant scrutiny for its rigidity, especially in rapidly evolving technology environments. Its sequential nature means that revisiting and making changes after a phase is completed becomes difficult and costly. This rigidity can lead to substantial issues if new requirements emerge or if initial assumptions are incorrect. Testing, which occurs late in the development process, often uncovers problems that are expensive or time-consuming to rectify. This delay in integrating feedback can result in projects not fully meeting customer needs or expectations. Furthermore, there is a pronounced emphasis on adhering to the initial plan, budget, and timeline, which can sometimes hinder the ability to adapt to changing conditions or evolving customer needs. The structured approach of the waterfall model laid a strong foundation for project management. However, as technology and market demands have evolved, its limitations have become increasingly clear. Concurrently, the iron triangle. Central to traditional project management was the iron triangle, also known as the project management triangle, a framework that emphasized the interconnections between scope, time, and cost. This model posited that any change in one constraint necessitated adjustments to the others, often at the expense of the project's quality. Despite aiming to deliver projects within predefined specifications, the iron triangle's rigidity contributed to a lack of adaptability and responsiveness. This highlighted the limitations of the predictive project management approach, especially in a dynamic technological environment. The iron triangle's rigidity within the waterfall framework made it difficult for projects to incorporate new customer requirements or adapt to technological advancements. Consequently, products often became outdated even before reaching the market, underlining a critical flaw in the traditional approach. The sequential nature of the waterfall model means that feedback is typically gathered late in the development process. Late integration of feedback can necessitate rework, leading to project delays and ultimately, products that fail to meet customer needs. The iron triangle's focus on sticking to initial scope, budget, and timelines often sacrifices quality and customer value. This overemphasis on adhering to the plan exacerbates delivery challenges, pushing teams to deliver at all costs. Constrained by the iron triangle, teams facing immovable deadlines and budgets may compromise on work quality. This can lead to dissatisfaction and potential market failure of the product. These challenges stem from the foundational principles of both the waterfall model and the iron triangle. The waterfall methodology's rigid, linear approach to software development, combined with the iron triangle's constraints on scope, time, and cost, leads to projects that struggle with adaptation, timely feedback integration, adherence to beneficial changes, and ultimately, the delivery of quality software. These challenges culminated in the application development crisis, characterized by a notable 3-year lag between identifying a market need and delivering a viable software solution. The application development crisis was more than just a symptom of outdated project management methodologies. It was a signal of a deeper problem within the software development industry. The crisis revealed a fundamental mismatch between the speed of technological evolution and the pace at which traditional methodologies like the waterfall model and the iron triangle could deliver software solutions. This mismatch resulted in several key issues. Projects often experienced a 3-year lag from concept to delivery, rendering them outdated due to rapid market changes. This delay resulted in projects that were misaligned with current business needs, causing dissatisfaction and market failure. Additionally, the inability to quickly adapt led to frequent project abandonment, wasting resources and increasing costs, often resulting in premature termination. Furthermore, completed projects frequently failed to meet evolving business requirements, missing market opportunities and leading to abandonment and financial loss. The application development crisis served as a wake-up call, prompting a re-evaluation of traditional project management and development methodologies. The shift towards agile practices was not just a trend but a necessary evolution to address the inherent challenges of software development in an ever-changing technological landscape. As we continue to explore the impact of this shift, it's clear that the principles of agility and flexibility have now become central to the philosophy of modern software development. In response to the pressing challenges of the application development crisis, the software development community began a journey towards a more adaptive methodology. Transitioning to agile methodologies didn't happen overnight, but was a gradual evolution. It demanded moving away from the traditional, linear approaches of the waterfall model and navigating beyond the constraints of the iron triangle. This shift towards a more flexible, responsive, and value-driven approach reflected the industry's commitment to adaptability and improvement, underscoring the collective effort required to redefine the criteria for success in software development. This journey was punctuated by the introduction of key methodologies such as Scrum, Extreme Programming, and the Dynamic Systems Development Method, and many more, leading up to a significant milestone in 2001 with the creation of the Agile Manifesto. This collection of methodologies signaled a shift towards methodologies that are more adaptable, responsive, and collaborative, marking a deep-seated change in mindset towards prioritizing adaptability, customer value, and team collaboration. It demonstrated a nuanced understanding of the fluid nature of software projects and the critical importance of agile response to change, incorporating the fundamental principles of the Agile philosophy. The crafting of the Agile Manifesto in 2001 was a defining moment, articulating the core values and principles that now underpin this mindset and philosophy. This moment didn't just highlight the evolution of methodologies, but also underscored a significant shift in thinking towards adaptability, customer focus, and collaboration. It illuminated the dynamic nature of software projects and the essential role of swiftly adapting to change, thus embedding the core tenets of Agile into the fabric of software development. This evolution from crisis to transformation showcases the industry's resilience and commitment to innovation, emphasizing how a steadfast focus on continuous improvement, adaptability, and customer value can lead to profound changes in project management and execution. Now that we've explored the reasoning behind the evolution to Agile, in the upcoming videos, we will dive into the details of Agile principles and practices,